Okay, today we discuss the valency shell electron pair repulsion theory. Valency shell electron pair repulsion theory. So in short form, it is also called VSEPR theory. Okay, VSEPR theory. So actually, this was proposed by Gillespie and Nyholm. Okay, so mainly it tells about it was proposed by Gillespie and Nyholm. It mainly tells about the shape of molecules. Okay, it mainly describes about the shape of molecules. According to this theory, according to this VSEPR theory, the shape of a molecule depends. Shape depends on a The shape of a molecule depends mainly on the number of lone pair and bond pair of electrons present at the central atom. Okay, so the shape of a molecule, a total theory mainly describes about the shape of the molecules. So according to this theory, the shape of any molecule depends on the number of lone pairs and bond pair electrons present at a central atom. Present at a central atom of the molecule. Means the shape of molecule totally depends on the position of central atom. Okay, we need to know about the lone pair of electrons and bond pair of electrons present on the central atom. And the total shape depends on the central atom's position, means the character of central atom, how many bond pairs it has, how many lone pairs it has. Okay, so now see what is mean by this bond pair, what is mean by this lone pair of electrons. Okay. So bond pair of electron means so which are participated in bonds. Okay, bond pair of electron means for instance. So bond pair of electrons. So bond pair of electrons means the electrons which are present in a bond. The electrons present in a bond, in a covalent bond. Generally, this total theory is explaining only about the covalent bonds, not about the ionic bond. Okay. So in the formation of covalent bond, we know that overlapping takes place. Okay. For example, in the formation of HCl, this is s orbital of hydrogen. This is p orbital of chlorine. The bonded electrons are like this. Okay. So these are all called. These electrons are called bond pair of electrons. Generally we treat it as BP centimeter bond pair of electrons, BP electrons. Okay, so means the electrons used in the bond formation are called bond pair of electrons. Okay, next so this part, okay, the orbitals, okay, these two orbitals involved in bond formation. Okay, this part is overlapping part. In this overlapping, the s orbital is present, here p orbital is present. The orbitals which are used for overlapping, for a bond formation are called localized orbitals. Okay, they are known as localized orbitals. That bonded electrons are also known as localized electrons. Localized electrons, bond pair of electrons. That orbitals which are having that bond pairs, nothing but which are used for the bond formation are called localized orbitals. Okay, now we see, so what is about the lone pair of electrons? lone pair of electrons. So lone pair of electrons means, for example, if you see an NH3 molecule, we know that nitrogen involves in sp3 hybridization. At one position, one sp3 hybrid orbital having lone pair of electron. We can write like this. In normal way, we generally proceed writing like this. Nitrogen has one lone pair of electron. Means it is also present in an orbital. But it is not involving in the bond formation. Okay. Sometimes the side atoms are also having that lone pair of electrons. But in the discussion of the shape of molecule, according to valency repulsion theory, they given importance only for the lone pair of electrons and bond pair of electrons at the central atom only. Okay, in some molecules, here there is no lone pairs are present in the hydrogen. Maybe some atoms are having lone pairs on the side atoms also. But here we are discussing, according to this theory, only about the central atom. So the electrons which are not involved in the bond formation and they are present in the valency shell. Okay, valency shell lo undali. They are not present in the bond formation. They are not used in the bond formation. Are called lone pair of electrons. The orbitals which are having that lone pair of electrons. So alone these. Now this is known as what? LPs, lone pair of electrons. From onwards we say it as LP. LP means lone pair of electrons. That orbital, the orbital which is having, which contains these electrons is called delocalized orbital. Delocalized orbital, or these electrons are also known as delocalized electrons. Okay, are also known as delocalized electrons. Actually, the bond, for example, here we bond pairs and lone pairs check chedam. Around nitrogen, which all bond pairs are present? So, okay, bond lo 2 electrons. This is one bond pair. So, this is second bond pair. This is third bond pair. Okay, I am counting it. So, nitrogen is having how many bond pairs around it? It has 3 bond pairs. The nitrogen having 3 bond pairs around it. How many lone pairs it is having? 1 lone pair. It is having 1 lone pair of electron. If you see, the bond pair means it is perfectly bonded between 2 atoms. Okay, bond formation between 2 atoms. These electrons are also present between the 2 atoms. Take these electrons, for example, 2 electrons bond formation. Okay, so these two bonded electrons are under the attraction of a nitrogen nucleus and under the attraction of a hydrogen nucleus. Okay, under the attraction of a nitrogen nucleus and hydrogen nucleus. That's why their movement, a bond pairs movement, they are very less movement. Okay, they occupy very little space only because movement takkundi kabatti they occupied some space only. So, but if you see the lone pair of electron, lone pair is only under the control of one nucleus. If lone pair ante mana bond lo form avvalledu. The nitrogen paina lone pair only nitrogen attractions to undi. The other side there is no fixing. Kabatti its movement is somewhat higher. See, lone pair move avvadaniki manaki ekku possibility undi. That's why simply we say the space occupied by the lone pairs is higher when compared to the space occupied by the bond pairs, because bond pair of electrons are fixed in a nuclei of 2 atoms, but here the lone pair of electrons are only under the attraction of 1 nucleus. So obviously they are having more movement, for more charge per moment, they occupy more space. So this is about lone pairs and bond pairs. Okay, so this is according to VSEPR theory. It's also known as general VSEPR theory, but the perfect word is VSEPR theory. So it tells about the shape of the molecule in terms of the central atom and in terms of the number of lone pairs and number of bond pairs. And they also given some points about the space around the space occupied by the lone pairs and bond pairs. We know that just now we completed. And they also said, according to this theory, there is also some repulsion takes place between these electron pairs. There is also repulsions also takes place among this lone pair of electrons and bond pair of electrons. Okay, so just now we discussed that the bond pairs are perfectly fixed. For example, this is the bond pair. Okay, this is the bond pair. This is the bond pair. So these bond pairs are fixed between these two atoms. So this bond pair, this moment of this BP electron. Say for example, this is one bond pair. So this is one bond pair. So bond pair of electrons means negative charge. So negative charge kabatti negative charge. Their compulsory repulsions are present between them. Okay, the repulsions are all called. These are also electron pairs. These are also electron pairs. Both are negative charge. Negative. Same charge means repulsion. That is called BP repulsion. Means bond pair repulsion. Actually, this bond pair repulsion is very less and it is a negligible because there is a lot of distance takes place between the two bond pairs and the moment of the bond pair is also very less. The moment of bond pair is very less. Just now we discussed that they are fixed between the two bonded atoms. So bond pair repulsion is there, but it is negligible. It does not affect lot. It does not affect the lot of shape of the molecule. Next, see, there is also repulsion takes place between this lone pair of electrons and this bond pair of electrons. Okay, it is fixed. It not shows much movement. But this is the lone pair of electron having highest moment. So the moment ikkada two lowest moments antanemo repulsion is negligible. But here is more moment, here less moment. Due to the highest moment of this lone pair of electron, this bond pair of electron, there is somewhat high repulsions are present. So this is known as so here the repulsion can be seen that is LP and BP repulsion center. So the repulsion between the lone pair of electron and this the adjacent bond pair to repulsions. So this is called LP BP repulsions, lone pair and bond pair of electron repulsions. Okay. These are all considerable. They are not at all negligible. So ikkada BP negligible, very less. Ikkada LP BP somewhat more repulsion compared to BP. Ikkada both are fixed. Ikkademo BP fixed, LP is not fixed. So the moment ekku untadi kabatti it creates the highest repulsion. Okay, means LP repulsion is more than BP repulsion. Next, see, there is a possibility of so BP etla undo LP kuda possibility untadi. So LP possibility. So already we know the such shape of a H2O molecule. So you must read that hybridization topic and the shape and structure of the molecules. Here, can you guess how many types of repulsions are present? So this bond pair, BP repulsion. So this lone pair, this bond pair. There is a LP BP repulsion, lone pair bond pair repulsion. So here also LP BP repulsion. Here bond pair of electrons ఉంటాయి. LP BP repulsion. So can you guess other type of repulsion possible here? There is this is LP. This oxygen having two lone pairs. Here nitrogen is having only one lone pair. That's no problem. Okay, అక్కడ only BP LP BP నే ఉంది. ఇక్కడ BP BP ఉంది, BP LP ఉంది. Next there is also repulsion between the two lone pairs are also that is treated as LP LP repulsion. Lone pair electron repulsion. So it is very highest repulsion compared to the earlier one. ఇంతకు మనకి సో LP LP అంటే both are not under control. ఇప్పుడు BPC అంటేనేమో టోటల్ అండర్ కంట్రోల్ కాబట్టి BP so BP negligible. So LP BP low, so BP under control, but LP is not under control, under the control of only one nucleus. More it occupies more space with a high movement. So kabatti LP BP repulsion is somewhat more than BP BP. But again LP LP repulsions are very high compared to the LP BP. Ikkademo okati fixed okatemo more space. Ikkada both are highly movement. Rendu LP lone pairs kabatti they have very high movement. Means LP LP repulsion, we can say that LP LP repulsion is more than LP BP repulsion, and LP BP repulsion is more than BP BP. Generally BP BP repulsion is negligible. It does not affect the shape of the molecule. So why we are discussing about these repulsion forces and there? So due to these repulsion forces only there is a difference in the shape of molecule takes place than expected. Okay, so already we discussed that the NH3 so already we know that the CH4 NH3 H2O molecules hybridization. So what was the hybridization at the time? The hybridization of the carbon sp3, nitrogen was also sp3, here oxygen is also sp3. But what is the perfect shape of that molecules? This is tetrahedral, this is trigonal pyramid, this is just angular. Okay, so what is the bond angle here? It is 109 degrees 28 minutes. Here bond angle was 107 degrees. Here bond angle was 104.5 degrees. Means even all are undergoing in all these three compounds central atom undergoes sp3 hybridization, but they are having different shapes, they are having different bond angles. Why? Okay, so it can be understood now with the help of VSEPR theory. Okay, so why? Because due to the here see in methane molecule, so all are having only just BP BP repulsions on the methane low. In methane only BP BP repulsions are there which are negligible. So main thing ఇక్కడ అన్ని BP BPC ఉన్నాయి, BP 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 BP. So all BP repulsions కాబట్టి negligible repulsions. నెక్స్ట్ ఇంకోటి ఇక్కడ ఈ BP repulsion అన్ని BP repulsions సేమ్ ఉంటాయి కాబట్టి సేమ్ బాండ్స్ ఉన్నాయి, సేమ్ BP repulsions ఉంటాయి కాబట్టి దే సెట్ ఇన్ టు దేర్ ఓన్ పొజిషన్ ఓన్లీ. మళ్ళీ దాని పొజిషన్లో చేంజ్ కాదు, పర్ఫెక్ట్గా సెట్ అయిపోతాయి కాబట్టి షేప్ పర్ఫెక్ట్గా టెట్రాహైడ్రల్లో ఉంది. బట్ ఇన్ NH3 మాలిక్యూల్ ఫర్ ఎగ్జాంపుల్ NHలో sp3 కాబట్టి మనం వి గెస్ దట్ ఇట్ ఈస్ ఆల్సో హ్యావింగ్ టెట్రాహైడ్రల్ షేప్లో ఉండాలి. అంటే ఈ NH3 మాలిక్యూల్స్ ఇక్కడ సో బాండ్ యాంగిల్ కూడా ఎంత ఉండాలి, 109 degrees 28 minutes ఉండాలి. ఫర్ ఎగ్జాంపుల్ యాక్చువల్గా ద పొజిషన్ ఆఫ్ హైడ్రోజన్ లైక్ దిస్ అనుకుందాం. ఇక్కడ బాండ్ యాంగిల్ 109 degrees 28 minutes ఉండాలి sp3 కాబట్టి. ఓకే, సో బట్ ఇట్ ఈస్ నాట్ లైక్ దిస్. సో 109 కాకుండా ఇక్కడ ఎంత ఉంది బాండ్ యాంగిల్, it is just 107 only. So why it is means ఇక్కడ fourth bond is not present. The place of fourth bond there is lone pair is present. So lone pair ఉంది కాబట్టి ఈ lone pair కి ఈ bond pair కి ఏమైంది, there is some repulsions are formed. So repulsions are formed కాబట్టి the bond angle is somewhat decreased. Okay, and for example ఇట్లా ఎక్కువ bond angle తో ఉండాలి. ఇక్కడ LP ఉంది కాబట్టి రిపల్షన్ అయింది కాబట్టి ఏంది, సో ఇట్ కమ్స్ టు సమ్వాట్ నియర్, అంటే ఈ బాండ్ ఫిక్స్డ్. సో దీనికి రిపల్షన్ ఉంది అనుకుంటే ఇప్పుడు ఇది దగ్గర అయిపోయింది. సో ఎక్కువ ఉండాల్సిన బాండ్ యాంగిల్ ఏమైంది, ఇట్ బికమ్ సమ్వాట్ లెస్సర్ వన్. సో ఇప్పుడు యాక్చువల్లీ ఇట్లా బాండ్ ఉంటే 109 degrees 28 minutes అనుకుందాం. బట్ డ్యూ టు రిపల్షన్ వాట్ హ్యాపెన్, డ్యూ టు దట్ రిపల్షన్ its position become like this. So that's why bond angle changed from 109 degrees to 107 degrees. So mid side kuda ante, it is also LP-BP repulsions. Means due to the LP-BP repulsion. So BP are countless. Okay. So LP-BP repulsion valla the bond angle changed to 109 degrees and shape also become triangle pyramidal. Here also in H2O. In H2O, we know that it is like this H2O. Here two lone pairs are present and oxygen undergoes sp3 hybridization. So sp3 hybridization kabatti compulsory ikkada em expect chestam, we expect 109 degrees 28 minutes expect chestam. So but here also lone pair and lone pair bond pair, ఈ రెండింటికి LP ఉంది. ఇక్కడ LP ఈ BP ఈ బాండ్ పేర్ కి. సో LP రిపల్షన్ ఉన్నాయి, LP-BP టూ టైప్ ఆఫ్ రిపల్షన్స్ ఉన్నాయి కాబట్టి సో ఇట్లా ఎక్కువ బాండ్ యాంగిల్ ఏమైపోయిందంటే ఇట్ సైడ్ రిపల్షన్స్ వల్ల దే కమ్ టు సమ్ వాట్ క్లోజర్. ఓకే, సో కాబట్టి ఎంత క్లోజ్ అయిపోయిందంటే దే బాండ్ యాంగిల్ 109 నుంచి 104.5కి వచ్చేసింది. సో మనకి ఇక్కడ కూడా లోన్ పేర్ ఉంది, ఇక్కడ కూడా లోన్ పేర్స్ ఉంది. ఇక్కడ ఓన్లీ వన్ లోన్ పేరే ఉంది అంటే ఇక్కడ నీకు లోన్ పేర్ బాండ్ పేర్ రిపల్షన్స్ ఉన్నాయి. ఇక్కడ టూ లోన్ పేర్స్ ఉన్నాయి కాబట్టి దెర్ ఇస్ ఆల్సో పాసిబిలిటీ ఆఫ్, సో దీంట్లో LP రిపల్షన్ ఉంది, నెక్స్ట్ LP-BP రిపల్షన్స్ కూడా ఉన్నాయి. BP కామన్ అన్నిట్లో ఉంటాయి. ఇక్కడ LP-BP ఉంది, LP ఉంది. బోత్ టైప్ ఆఫ్ రిపల్షన్స్ ఉన్నాయి కాబట్టి బాండ్ యాంగిల్ డిక్రీజ్డ్ హైయెస్ట్. ఇక్కడ 109 to 107 వచ్చింది, ఇక్కడ డైరెక్ట్గా 104కి వెళ్ళిపోయింది. అండ్ బికాస్ ఇట్ ఈస్ ద ప్రెసెన్స్ ఆఫ్ టూ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్, ఇక్కడ వన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్. ఇక్కడ బాండ్ యాంగిల్ చేంజ్ అవ్వాలి పర్ఫెక్ట్గా. expected bond angle, the experimental bond angle are same because there is no lone pairs are present. But in the presence of lone pairs only there is a deviation takes place in the shape of the molecule and shape molecule that bond angle would change over. Means now we can conclude that due to the presence of lone pairs, due to the presence of lone pair of electrons on the central atom, there is a deviation takes place in the shape of the molecule than expected. The shape of the molecule changes means obviously there is a change in the bond angle takes place. So what is the repulsion forces order means LP is greater than LP-BP, okay, and LP-BP is greater than BP-BP. Like there is also one other order is given for repulsions. For example, a bond is present, a triple bond is present between two carbons. Double bond is present between two carbons. A single bond is present between two carbons. So carbon motta positions, so 4 undali kabatti we did like this. Okay, 4 undali carbon around counting always. So this triple bond is more repulsion than double bond. Double bond is more repulsion than single bond. So actually bonds, number of bonds increase avutante the distance between the molecule atoms decreases. Okay, single bond unnappudu some distance, for example as this carbon distance into the approximately 1.4 angstroms ఉంటుంది. అదే డబుల్ బాండ్ ఇంకో బాండ్ ఉంది కాబట్టి దే బికమ్ సమ్వాట్ క్లోజర్. సో అప్పుడు ఏమవుతుందంటే బాండ్ లెంత్ 1.34 యాంగ్స్ట్రామ్ అవుతుంది. అదే ట్రిపుల్ బాండ్ అయినప్పుడు ఏమవుతుందంటే ద బాండ్ డిస్టెన్స్ జస్ట్ 1.20 యాంగ్స్ట్రామ్ అవుతుంది. అంటే ద నెంబర్ ఆఫ్ బాండ్స్ ఇంక్రీజ్ అయితే అవుతాయంటే దే బికమ్ సమ్వాట్ క్లోజర్. సో క్లోజర్ అంటే ఆటోమేటిక్ ఏమవుతుంది, దే బికమ్స్ మోర్ రిపల్షన్. Means repulsion of triple bond is more than double bond, more than single bond. This is an example carbon, not between carbon atoms. In any atoms, if three bonds are present, there are more repulsion compared to the double bond, and double bond is having more repulsion compared to the single bond. Okay, right. This repulsion forces are also depends on electronegativity difference. The another factor is they also depends on electronegativity difference of that bonded atoms. Okay. So write the notes perfectly. Okay, continue this. Okay, so these are the main points of valency shell electron pair repulsion theory. So according to this, finally we can conclude that the shape of the molecule depends on the central atom and the number of lone pairs, bond pairs on the central atom and their repulsions. Kali we discussed the examples also, but we give that examples tomorrow with some more examples. Okay. And here in the last point we said that the double bond, triple bond, single bond, all electron pairs are treated as a single electron pair because they are all present in one direction. So therefore they treat as a one electron pair, but normal single electron pair treated as a normal pair. The double bonded, triple bonded pairs are treated as a super electron pairs. They treated as a super electron pair. And the repulsion forces also depend on the number of bonds. So the number of bonds changes the repulsion forces only due to the distance between them. Okay, not about the number of lone pairs, number of bond pairs, etc. So due to the triple bond, they become somewhat closer. That's why the more repulsion takes place. Okay, so explanation of examples we see tomorrow.